So, understanding evolution is what we're talking about this evening. Let's just go ahead and get into this. When we talk about evolution, we really have to start with a fellow whose name was Charles Darwin and the Beagle. That name, the Beagle there, that is a ship, okay? Charles Darwin was an English naturalist. He lived from 1809 to 1882. He sailed aboard the HMS Beagle on a 5-year voyage from 1831 to 1836. How many of y'all have ever watched the movie Master and Commander? All right, if you've seen the movie Master and Commander, you know that on the ship there is a doctor, and the doctor is always interested in what? Collecting specimens. And they actually end up where? There's an island chain that they end up in that movie. The Galapagos, okay? He's modeled after Charles Darwin, all right, because that really is what happened there. It was not unusual on British sailing ships of the time for them to have a doctor who was also a naturalist, and they would be looking for new things. I mean, it was the age of discovery. They call it that for a reason. So he made extensive observations and collected specimens on this 5-year voyage, okay? 5 years he is at sea. The time in the Galapagos Islands was particularly important for what he is later going to formulate as the theory of evolution. A couple of photographs here of Charles Darwin. Charles Darwin in the late 1830s. That gives you an idea of what he probably looked like about the time he was sailing. And then about 1854, as a considerably older man, after the voyage. That's what, 20 years or so after the voyage. This is a painting of the HMS Beagle, not a particularly large ship. It did have cannons on it because every British warship would have had some cannons. This is not one of their big battleships. It was a relatively small ship out sailing the world. This is an actual replica of the Beagle that you would have to go to Chile to see. I just look at that and I think, man, you spent 5 years on a ship like that. Okay, granted, going into ports from time to time, but still, 5 years on a ship like that with a lot of the same guys, cramped quarters. I guess it takes a special breed. At any rate, so he spent 5 years on a ship like that, made a lot of observations, collected a lot of specimens, and then as a result of all of that, he formulates a theory that really is a theory that has changed the world as we know it. He published the theory in 2 major books. The first of those was in 1859 on the origin of species. Now, we call that a lot of times Origin of the Species. That's not what it was entitled. It was entitled On the Origin of Species. Published in 1859. So that's about 23 years after the voyage is over. Okay? He doesn't come back to England and immediately publish this. It gels a little while in his mind as he's considering the theory and formulating the theory. He publishes a second book in 1871 called The Descent of Man. The Descent of Man gets considerably less treatment in circles today than the Origin of the Species than Origin of Species does. Usually this is what everybody thinks about. They don't think so much about this. The Descent of Man is also interesting reading if you happen to want to read his books. I've read The Origin of Species. And I've read parts of The Descent of Man. If you've never done that, you might pick up a copy of that and read that. You will be shocked by reading The Descent of Man because Charles Darwin has some very interesting ideas concerning the different human species. He was what? White and English. So take a guess at what would have been the highest evolved species. I don't think he would use that word, of men.
White and English.
White and probably English, okay? Who do you suppose were the less evolved or the least evolved? The African Americans, or Africans, not African Americans, Africans, okay? Asians would have been somewhere in between, okay? But definitely not as highly evolved as the white Englishman, right?
I disagree.
You disagree, okay? I agree with your disagreement, okay? So these are the books. This is the one that's well known. This is the one that is considerably controversial if it were better known today. Shelley?
How come you didn't finish the second book? You said you...
Oh, because I was only reading parts of it. This was required reading when I was in college.
Okay.
That was not, and so I didn't read all of that. But I've read excerpts from it. Okay? So those are his 2 books. Darwin's theories remain the framework of evolutionary thought. Okay? So when we talk about evolution in this class, his is the framework. I'm not saying that everything that he came up with hasn't been changed. Some of it has. But his theories are the framework for what we call evolution today. Some aspects have been modified. Others have been rejected since Darwin. But Darwin still provides the framework. So when we talk about things like survival of the fittest, that's Darwin. through and through. Okay, he may not have been the first one to come up with it, but he was the one that formulated it and published it, and so he's the one that we associate with that. So Darwin is really, really important for evolution. All right, so what is evolution? What are we talking about this evening? Well, evolution involves the change in the heritable traits of organisms over successive generations. What are heritable traits?
Stature.
Okay, that's in the Angstrom 1, stature, how tall you are. Okay, there are things that you can inherit from your parents. So, for example, Ivana has blue eyes, I have green eyes. Every single one of our children are born with
Blue eyes.
blue eyes. Okay, blue eyes is apparently dominant over green, and I lucked out. I didn't get a single green-eyed child in the whole bunch. All right, none of them would have been born with brown eyes. Okay, but that's a heritable trait. Adela wears glasses. Anna wears glasses. Sam wears glasses. I wear glasses. Ivana wears glasses. Boy, go figure that, right? Okay, I've inherited some of the illnesses, some of the diseases that I have. I have inherited from my parents. Sometimes I jokingly tell my parents that if they had known when they were younger what diseases they were going to have when they were older, they probably should not have reproduced and passed those genes on. But, find these things out until you've already had children. So there you go. These are things that you inherit from your parents and successive generations back. This particular process gave rise to biological diversity, and all life on Earth shares a common ancestor. Okay? If you trace everything back, and we're going to see some trees here in a little while, if you trace everything back, eventually you're going to get to a common ancestor. So, humans, I want to clarify this. Sometimes people say, well, evolution says humans are descended from apes. No, we're not. But apes and humans, according to evolution, are descended from a common ancestor who admittedly looks more like an ape than a human. I will grant that. But we are not descended from chimpanzees or gorillas. They are our cousins, okay? According to evolution, all right? Natural selection is the driving force. Natural selection being that certain traits allow you to survive, okay? And if you survive, you're going to have more time to pass on your genes, okay? And because of that, those genes are going to pass on. They're superior genes. They allow your descendants to continue that process. All right. So this is an actual photograph from Darwin's journal that was unpublished, okay? It illustrates his concept of the tree of evolution. I'm not going to even try to pretend to read the handwriting, but basically if you see this kind of a design, here's our common ancestor, and then all the life from that tree goes off in various directions. A more modern drawing of that would look like this. This is what's called the phylogenetic tree of life. This is a modern understanding of science. So the modern understanding that science has, according to evolution, okay, you go back to an original ancestor, and then eventually it broke off into all of these other branches. So you have all the bacteria over here. Well, you know bacteria, right? They make us sick. They give us stomach bugs from group meetings and things like that. We just had that recently. Then you have archaea. I have no idea what those are. Don't even ask me. I'm not a biologist. But it's another tree, another branch on the supposed tree of life. And then you have the eukaryote. I have no idea what that is, except these are more familiar to us. So plants, fungi, slime molds, and animals. And what's important for us is that evolution classifies us as
slime mold.
No, slime molds are our cousins. Okay? Do not speak disparagingly of slime molds. Animals, all right? That's where we fit in on the tree of life. But eventually, if you trace all that back, you get some kind of common ancestor that eventually gave rise to everything that we see on Earth today. That's basically evolution, and it's doing that through natural selection. Some species, some life forms are better suited for survival. They reproduce. The classic example that's given are dark moths and light-colored moths in England during the Industrial Revolution because the pollution made the trees dark, so dark moths could survive because they were camouflaged, whereas white moths stood out like a sore thumb. The birds ate them. They didn't reproduce. So hence, today, what kind of moths are there? Lots of dark moths, apparently. Okay, so that's a classic example that's given for survival of the fittest. You do not need evolution to believe that. Okay. How many of you are of European descent this evening in this room? Raise your hand if you're of European descent. All right. If you're of European descent, chances are today you have a nice genetic mutation that makes you more able to survive the bubonic plague. Because if your ancestors lived in Europe, when the plague went through, it wiped out millions of people. And it basically left people behind that had this genetic mutation. They survived. They passed that genetic mutation on to their children. And so today, most people of European descent have that genetic mutation, which is really, really good because bubonic plague is still a thing. Okay? Now, it is entirely possible, Mimi, this is for your benefit, it is entirely possible that people in Asia also have that genetic mutation because bubonic plague went through Asia before it hit Europe. Okay? So it devastated Asian populations like it did European populations. Evolution would say that's survival of the fittest. I would say that's survival of the fittest, but no new life forms are created. Okay? So there is a distinction between the two. Evolution says if you keep going down that path, you get all of these life forms. All right, so natural selection, again, is the driving force. Traits vary among individual organisms. We can see that here in the room tonight. We've got some people who are tall. We've got some people who are short. We've got some people who have blonde hair, brown hair, green eyes, blue eyes, brown eyes, and so on and so forth. We're all individuals. We all have different traits. Different traits, however, can confer different rates of survival and reproduction, hence survival of the fittest. Good traits are then passed on to offspring, which makes them better equipped to survive and pass on their traits. All right? Those that don't, white moths in England, okay, don't survive because they have not adapted to the new environment, which is dirty trees because of the Industrial Revolution, or at least so the theory goes. Okay? Chance genetic mutations produce variations in traits. All right? So, let's say something like, I have green eyes, I do. Ivana has blue eyes. Two of our kids are born with blue eyes. Let's say the third one is born with a blue eye and a green eye. That would be a chance genetic mutation. It does happen, okay? It's kind of rare, but it does happen that you can get different colored eyes on the same individual. That produces a variation in traits, and of course, if a trait helps you survive better than the organisms that don't have it, then you're going to pass those traits on to your offspring, who are then going to pass it on to their offspring, and so on and so forth. Looks kind of like this, and you have this in your papers as well. All right, so you've got organism up there at the top. He's dark red. He produces through reproduction and mutation. He gets variation. So he ends up with a white descendant, a dark red descendant, and a pink descendant. Okay. Unfortunately, the white descendant is a white cat living in a very, very dark jungle. So he sticks out like a sore thumb. We're going to X him out because the snake gets him quickly, okay, or whatever gets him quickly, because that doesn't help him being white in that environment. The dark red and the pink continue on. They survive that. They're both quite capable of surviving where the white individual does not. The red then produces red offspring, dark red offspring. Pink, we get a pink offspring, and then, whoa, another mutation, we get red. Okay? Then, for whatever reason, circumstances have changed, and dark red is not favorable, and so these descendants get eaten by the snake. Okay? They're gone, they don't reproduce, but pink and red, they're still favorable in that environment, so they continue on producing children that then pass that trait on. And so you started out, I want you to notice this, you started out with a dark red individual, and in the end you end up with just pink and medium red. No dark red individuals exist anymore. White are gone earlier than the dark red, but the dark red are gone as well. That's natural selection. That's how that works. This is in a nutshell, this is a simplified form, but that's how it works. Okay? And so evolution, Darwin's theory, says that all the diversity we have in life on the earth is a result of this process. And if you give it enough time, and evolution requires a lot of time, okay, then you're eventually going to get the diversity in life that we have today. All right, so let's look on a little bit. We need to talk about micro versus macro evolution, because honestly, you may have heard some of this explanation, and you may have said, well, that sounds reasonable to me. Let's talk about that. What is microevolution? Microevolution represents changes within species. And the result of that are variations within the species. Okay? So, microevolution, I'm going to have a couple of charts here in a minute that will kind of demonstrate this. But microevolution would be the fact that, let's see, anybody here raise chickens? Anybody here ever raise chickens? Did y'all ever have chickens? No, y'all never had chickens. Anybody here have farm animals? Nobody had farm animals. Bill had farm animals, Shelley is saying. Okay. Bill, let's say your chicken hatches, and it's got 2 heads. Now, as a good chicken farmer, what are you going to do to that chicken?
Cook it.
You're going to cook it. You're not going to let it reproduce, right? Because every farmer knows that if you let a defective animal reproduce, you're going to get more defective animals. Okay? But you would never think of saying, that's actually not a chicken, that's a turkey. Right? Because it's chicken. It's still a chicken, even with 2 heads. Okay? Microevolution results in variations within the species. If you were to go back in time about... Oh, well, we'll just go back 2,000 years. We don't have to go back farther than that. 2,000 years ago, how many different species of dogs were there? How many different kinds of dogs were there? They're all one species. How many different kinds of dogs were there? Not many. There were a handful. Okay? Over 2,000 years, human beings have been selectively breeding dogs. And so you have this Great Dane on one side, and you have a Chihuahua on the other side. Are they both dogs? Yes. Are they capable of reproducing? Yes, they are. Okay, I don't know mechanically how that would work, but it could happen with scientific intervention. You can cross a Chihuahua and a Great Dane. I have no idea what you can get out of that. But it would be interesting to try. So if anybody has a Chihuahua and a Great Dane, I would love to see the results of that crossing. But everybody looks at that and they say it's a dog. Okay, they're still dogs. All right. If you cross the Great Dane and the Chihuahua, you do not end up with a what?
Cat.
You don't end up with a cat. Okay, that's microevolution. Everybody believes in that. I believe in that. You believe in that. We see it all the time. Every farmer understands that. Macroevolution, however, is really what we're talking about this evening. Because macroevolution says that changes cause one species to give rise to another. So, the Great Dane and the Chihuahua produce something that is not a dog. Right? That's, again, oversimplification, but that's what evolution says, macroevolution. So really what we're talking about tonight, we have to keep the two separate, because if you're talking with someone, remember this is classical evidences, you're talking with someone who believes in evolution, and they're using this as their point about evolution, steer away from that. Everybody believes in that. Nobody disagrees with that. Okay? This is the issue right here. New species arising through genetic change. Kelly?
It is my understanding that Darwin did not separate those two, though. That was part of his problem. He had no distinction between micro and macro.
That's exactly right, and that's exactly what you find when you're looking at even how it's talked about today. Our moths example in England. Okay, there's no new species of moths. They're all the same moths, just the white ones didn't survive because they were on dark trees and the birds got them. So, but you take something like that as an example of microevolution, and it makes perfect sense, doesn't it? So then they extrapolate and say, that's the same as macroevolution. And the distinction is lost on a lot of people. So they mix the two together, absolutely. But there's nothing revolutionary here. People have understood that probably since people started reproducing sheep. So for example, our sheep, there we go, there's one of our pictures. Macroevolution, how many different kinds of sheep are there? That's a trick question. There are a lot. There are a lot of different kinds of sheep. But they are all in the end what?
Sheep.
Sheep. They're not cows. Okay? They're sheep, right? And you could look at sheep. You could look at chicken. You could look at cows. Okay? By the way, you can look at people. These are not different sheep species. They're different kinds of sheep. People are all the same, aren't they? It doesn't matter if you're from Africa or from Europe or from Asia. People are all human beings. And they can clearly intermarry with people from humans from other parts of the world. And what do they produce?
Humans.
Humans. Okay? They produce humans. It's the same thing. Okay? By the way, Adam and Eve were
Humans.
humans. Okay? Were they white? brown, black, who knows? Okay? Given the part of the world they're from, they were probably not English looking. Okay? But in that genetic material is everything. So as people have diversified and gone to different parts of the world, which, by the way, what Bible story illustrates very well how that happened and why that happened? Babel. So as they go to different parts of the world, the genetic traits that are dominant in those places remain the dominant traits. Okay? And sometimes we kind of lump everybody into the same category, right? Right? If we're I hate to say it this way, but if we are white of European descent, we probably lump everybody in Asia in the same category, right? Probably do. Mimi would beg to differ and say there's a huge difference between Chinese, Japanese, and maybe Vietnamese. They're all from Asia, but physically they generally look different. Okay, my understanding is the Japanese tend to be much taller than other people in Asia. And Tom up here is are you a quarter or a half? Half. He's half Japanese, so he can speak, right? Stand up for a second. No, don't do that, Tom. Tom's very tall, all right? So we just kind of lump everything in together. But even within groups, there are variations. Okay, is Ivana white? Yes. Do Czechs look different than English? Yes, they do. Okay, and so if you spend time with those two groups, you can see the differences. They're all white, but they look different. Okay, they're all sheep, but they look different. That's microevolution. This is macroevolution. That's different. That's a one-cell organism of some sort that eventually gives rise to an octopus, a tortoise, and a bat. And everything else. We're on there as well. Because that's that primeval form of life. And over time, over lots of time, millions of years of time, billions of years of time, from macroevolution, you get this diversity. Okay? The problem I have, this is in a nutshell, this we see. We see it all the time. Okay? This we don't see. Ever. It's extrapolated. Okay? Evolutionists say you can go from this to this. The problem is, this we see, this we don't. And therein lies the problem. So to take microevolution and say because it's true, macroevolution has to be true, is making a jump that we don't observe. And because we don't observe it, remember way back at the beginning of this class we talked about what science requires. It requires that something be capable of repetition and capable of observation. We have neither repetition nor observation for this. This, yes. This, no. All right, make sense? All right, so let's keep going. Requirements of evolution. I'm on a roll because I'm talking really, really fast and I don't want to get this lesson done. Requirements of evolution. Time, lots of it. Okay? And it keeps getting pushed back longer and longer and longer. How old is the Earth? I don't know what it is today. It was 6 billion years and it's probably been pushed out some more. You need a lot of time to get evolution. Right? Advance is done through beneficial random genetic mutations. And it requires a progression from simple to more complex. It requires also that in the beginning, non-life gave rise to life. That is absolutely a requirement. Now, what some scientists have done is they have said, well, yeah, we know non-life doesn't give rise to life. So where did the original life come from here on Earth?
Somewhere out in space.
Somewhere out in space. It landed on a meteor. Okay? So, boom. Plop down on Earth a bacteria. And given evolution, that bacteria just grew and grew and grew and changed until we have everything we have today. Okay? All that does is it pushes back the time limit. That's all it does. It doesn't change anything. Because you still have to explain how you got a bacteria on a meteor from somewhere else to get here to Earth. So, it requires all of these things. I might also point out, because I don't think we're going to do this tonight, beneficial random genetic mutations. How many of y'all are just dying to have a genetic mutation? Anybody? If we could wave a magic wand and I could give you a genetic mutation randomly, anybody stepping up for that offer? No, Because we know that genetic mutations almost always are
non-beneficial.
non-beneficial. That's exactly right. Okay? So we don't like genetic mutations by and large. Remember back, it was a long time ago, everybody was all worried about the ozone, the hole in the ozone. Remember that? Nobody talks about the hole in the ozone anymore, but they were talking about that because now more UV radiation is going to reach the Earth, and UV radiation does what? Causes mutations. Okay, so we got to fix that ozone hole because that's not a good thing. Bob, you had some skin cancer removed, didn't you? On your forehead? Lots of people have had that done. If you haven't had it done, chances are you will eventually have it done. Where in the world does that come from?
The sun.
The sun. That's exactly right. UV radiation producing unfavorable mutations. Evolution says unfavorable mutations. No. That gets wiped off the record. It's all about the good genetic mutations. Are there some good genetic mutations? There really are if you're living in Europe in the 1300s and you have one that allows you to survive bubonic plague. That means you and your children get to live to see another day while 90% of your neighbors all die. They don't reproduce, their children, well, if they already reproduce, their children die as well. You and your kids get to survive. You pass that on, so you get to survive the bubonic plague. And the next time the bubonic plague comes through Europe, guess what? Your grandchildren get to survive, and your great-grandchildren get to survive. That's why the plague burned itself out. Because it had burned through population that were susceptible to it. And those that remained were not as susceptible to it. And so they may have gotten sick, but they generally didn't die. That's a beneficial mutation. Okay? But most mutations are not. And so no one just says, hey, I'm going to go lay in a tanning bed for 3 days straight to see if I can mutate a little bit. All right? Natalie over here is pregnant. Natalie, during pregnancy, like every woman during pregnancy, has limited her exposure to certain things that can harm the baby, right? You're probably not going to real smoky bars to have dinner, right? Yeah, no, because you don't need to be breathing that smoke, right? Because it's not good for you, not good for the baby either. Yvonne and I lost our first baby. When she was pregnant the first time, we lost that baby. We lost that baby because she took some medicine. She didn't know she was pregnant, and the doctor didn't do a test, just prescribed the medicine. She took the medicine, and then we found out she was pregnant. Went to see the doctor said there were two possibilities. Baby's going to live, baby's going to die. That was it. As it turned out, we lost the baby. Right? It harmed the fetus. Had the baby been born, we don't know whether it would have been born with some genetic defects because of that. It might have been, might not have been, I don't know. But generally speaking, genetic mutations, no, they're not good. We don't want those things. Okay? Things that are not required by evolution, there is no requirement for design or guidance, since all is due to blind chance or unguided processes. Think about all the dogs that exist today. Why do we have an Australian Shepherd at home? And Meanie and Stephen, what do y'all have?
Mutt.
A mutt. Does it lean in what? How does it identify? How does it self-identify?
As an idiot.
Clearly, its parents should not have been allowed to reproduce, right? All right, let's see. Sherry, do you have a dog at home?
Yes.
What do you have at home?
Well, he's a mixture of a Jack Russell and some kind of terrier.
We're going to call him a terrier. How about that? That's just going to cover the whole basis. Why is it we have a terrier and an Australian Shepherd? Because people selectively bred. People intelligently selectively bred. Okay? Just like the two-headed chicken. You don't let a two-headed chicken breed. You take it right out of the breeding pool because you know that's not a good thing. Okay? Good chicken farmers, and I don't know if Bill was or wasn't a good chicken farmer, good chicken farmers also tend to look at their hens and see which ones are laying the best eggs. And the ones that aren't end up in the stew pot, and the ones that are get to keep producing eggs. And some of them you're going to let hatch so that you get more good producing chickens. But who's guiding that? Bill the chicken farmer. And we will all agree that Bill the chicken farmer is intelligent, right? See, I knew Shelly would over there do something. Of course he is. Okay? He's guiding the process. Evolution says there's no requirement for that. It is all blind chance. It is all blind chance. Unguided processes. Okay? There is no requirement for a supreme being. There is no requirement for God. Now, what has happened is people who want to believe in God and evolution have chosen to try to mix the two. But the reality is evolution does not require any deity at all. It is merely believers who have come in later and tried to insert God back into the picture. Because we don't like the idea of not having a God. So we're going to stick God back in there. But we're going to stick a God back in there that does what we want him to do, which is guide evolution. Regardless of what that God has also said about what he has actually done. Alright? So, no requirement for that at all. By the way, let me just throw this out there. You will occasionally read that Charles Darwin repented of his error on his deathbed and went back to believing in God. That is false. He died an unbeliever. Okay? He had been raised in a religious household. As a matter of fact, the other possibility, instead of being a doctor, was for him to have become a vicar in the Church of England. Okay? He was raised in a religious household. He completely repudiated that. That bothered him. Okay? It bothered him because he understood that there might be some consequences to all of this evolution talk, and indeed there are some social consequences. Okay, so ignore that blue box. It was supposed to come up later, and there it is. Social Darwinism is a social consequence. It's the application of evolutionary principles to society. So, for example, we have eugenics, which is an attempt at bettering the gene pool through selective breeding and sterilization. This is a real thing. It was a real thing in America prior to World War II. And after World War II, Americans who were involved in eugenics said, ooh, those Nazis did all sorts of nasty things with eugenics. It got a bad name. Should have had a bad name from the beginning. But it got a bad name, so we're going to distance ourselves from eugenics. This was a big thing in the past. By the way, what's the lady who established Planned Parenthood?
Sanger, Margaret Sanger.
Yeah, big eugenicist. You know who she was hoping would get most of the abortions? Black people. Yep, exactly. This is well documented in their own words and in their own writings. Okay, this is not some kind of it's not something that Stephen is making up in the class. These eugenicists were opposed to. Well, they would have looked at your dog and said, "Idiot, sterilized." But they're looking at people, not animals. Okay, so. These people shouldn't reproduce. People who were born with mental defects, not allowed to reproduce. People with mental diseases, not allowed to reproduce. How were they not allowed? They were sterilized. Against their will, and sometimes against their knowledge. There were people who later, after years of trying to have babies, couldn't figure out why they couldn't have babies, and then they found out that what the doctor said was you're getting your gallbladder removed actually was their organs being removed so they could not have children. Because somebody had deemed them unfit to reproduce. Eugenics is an effect of that. And yes, in Germany, particularly in World War II, prior to World War II, it really reached the pinnacle of where it could go. National Socialism is a social consequence of Darwinism. Euthanasia, killing less desirables. People with mental illness in Nazi Germany were killed. People of less desirable races, which was basically anybody but Germans, were killed or worked until they could be killed. Okay? Hitler had, for example, the Czech Republic, Czechoslovakia, the Czech part of that. He didn't kill those people in any huge numbers because they were useful to him. They were working in industry that provided for the German war effort. But Hitler's plans for the Czechs were well known. Once the war was over, there's a lot of good farmland in the Czech Republic. We're going to make sure that it gets settled by Germans. What do we do with all those Czechs? Well, we've got some camps out east that we use to get rid of the Jews. We'll use that on the Czechs as well. And the Poles, and the Gypsies, and anybody that they thought was less worthy of life. As a matter of fact, they had a word for it in German, Untermenschen, subhumans. That was a real thing. That isn't something the Americans made up. Okay? So that's the result. Interestingly enough, communism is also a social consequence of social Darwinism. Racism also, remember the descent of man? Darwin's view that certain races of men were higher evolved than others. Okay? And of course, increased atheism and unbelief. Now, we should note that consequences do not invalidate evolution as a scientific theory, but theories have consequences that we should acknowledge. So just because these things came out of evolution doesn't mean evolution isn't true, but theories have consequences. So when you get God out of the picture, when you tell people that some are higher evolved than others, these things are going to result. And they have. So, This is a quote from The Descent of Man. With savages, the weak in body or mind are soon eliminated, and those that survive commonly exhibit a vigorous state of health. We civilized men, on the other hand, do our utmost to check the process of elimination. We build asylums for the imbecile, the maimed, and the sick. We institute poor laws, and our medical men exert their utmost skill to save the life of everyone to the last moment. There is reason to believe that vaccination has preserved thousands who, from a weak constitution, would formerly have succumbed to smallpox. Thus, the weak members of civilized societies propagate their kind. No one who has attended to the breeding of domestic animals will doubt that this must be highly injurious to the race of men. It is surprising how soon a want of care, or care wrongly directed, leads to the degeneration of a domestic race. But excepting in the case of man himself, hardly anyone is so ignorant as to allow his worst animals to breed. Not too hard to figure out why that quote doesn't make itself into the media, does it? It shows exactly what these folks were thinking. All right, so Sir Francis Galton, who was Darwin's half-cousin, by the way, and founder of the eugenics movement, said one of the effects of civilization is to diminish the rigor of the application of the law of natural selection. It preserves weakly lives that would have perished in barbarous lands. So those that are weak, let them die. Okay? And that's good. That's good for the preservation of our society. Stephen Jay Gould said this in 1977. Biological arguments for racism may have been common before 1859, publication of On the Origin of Species, but they increased by orders of magnitude following the acceptance of evolutionary theory. God says what? All men are created in His image. All men are descended from Adam and Eve. All men are what?
Made in the image of God.
Made in the image of God. We are all one family. Okay? And that means that we love people who look different than us, that talk different than us. We treat them the same as we would anyone else. Evolution opened the door for a completely different way of looking at that. All right. Another quote. This is from Thomas Huxley. It may be quite true that some Negroes are better than some white men, but no rational man, cognizant of the facts, believes that the average Negro is the equal, still less the superior of the white man. And if this be true, it is simply incredible that, when all his disabilities are removed, and our prognathous relative has a fair field and no favor, as well as no oppressor, he will be able to compete successfully with his bigger-brained and smaller-jawed rival. Who are the bigger-brained, smaller-jawed rivals? Caucasians, yeah, Westerners, all right. In a contest which is to be carried on by thoughts and not by bites. The highest places in the hierarchy of civilization will assuredly not be within the reach of our dusky cousins, though it is by no means necessary that they should be restricted to the lowest. Thomas Huxley, who is otherwise known as Darwin's Bulldog, in his book, 1865, Emancipation, Black and White. Wow. Biology textbooks aren't putting that inside, are they? All right, another quote. Adolf Hitler. I don't often quote you Adolf Hitler in Bible class, but here we go. In an unpublished manuscript, he said this: while nature only allows the few most healthy and resistant out of a large number of living organisms to survive in the struggle for life, people restrict the number of births and then try to keep alive what has been born, without consideration of its real value and its inner merit. Humaneness is therefore only the slave of weakness, and thereby in truth the most cruel destroyer of human existence. You ever wondered how German soldiers could shoot men, women, and children in the backs of their heads, and do it by the millions? And I don't just mean SS soldiers. There were plenty of German Wehrmacht soldiers that did it as well. When you indoctrinate an entire generation to believe this, and the one you are killing is weak and a competitor to the superior race, it makes that a whole lot easier. And that's why they did what they did. Oh, let's see. Karl Marx. Why not? Let's throw him in there. On Darwin's book, On the Origin of Species, the quote is from December 1860, said, although it is developed in the crude English style, this is a book which contains the basis of natural history for our views. Of course, Karl Marx is one of the progenitors of communism. It was the big competitor of National Socialism in the early 1900s. It still exists today. We don't have Nazi governments anywhere today, but we still have communist governments, don't we? Vietnam, People's Republic of China, Cuba, some other places as well. All right, so Marxism is alive and well. Friedrich Engels, who is that other fella, along with Marx, who comes up with this theory of communism, said Darwin, by the way, who I'm reading just now, is absolutely splendid. There was one aspect of teleology that has yet to be demolished, and that has now been done. Never before has so grandiose an attempt been made to demonstrate historical evolution in nature, and certainly never to such good effect. So you got Hitler praising Darwin. You got Marx praising Darwin. You got Engels praising Darwin. And how many, between those two philosophies, how many millions of people died at the hands of those philosophies just in the 20th century? When you think about the numbers killed by the Nazis, that's what we always remember. We should remember that Stalin's Russia, Soviet Union, murdered an equally large number. Okay? And the People's Republic of China has been busily killing people as well, and all on the basis of a philosophy that is a consequence, a social consequence of this theory. All right, any questions or comments about that? We got a few minutes left in class. We'll stop, give a break, catch my breath.
I don't like to hear about those things.
You don't like to hear about those things. I agree. They're unpleasant. But we need to. Because evolution isn't just some benign theory that's taught in schools. It has consequences. Beyond the fact that it leads a lot of people to unbelief, it has consequences right here on the earth that we can see.
And school, you think, is one of the public schools?
Well, they're not going to say that right there that he's just talked about.
Yeah, they're not going to quote that. That's not in the biology textbooks. But evolution is taught in the public schools. I think Sam first encountered it in elementary. Wow. Here at Northwest ISD. It was really kind of not funny, but he had a teacher who's a member of the church. I won't mention names because we're on video. Don't want to get in trouble. And when they did evolution in the class, and this was like, I don't know, it was elementary school. And she said, well, that's certainly one view of how life got here. And she said, basically, that there were other views about that as well. But it's pretty much taught across the board. It's assumed to be true. It's assumed to be true. There's an assumption that it's true in the schools. Very, very different. I encountered evolution in a public school in high school, in biology in high school. And we argued about that for about 2 weeks until the teacher said, finally, we're gonna move on. But she allowed discussion. And there were a couple of us that disagreed with it and voiced that disagreement. And she allowed that for a while, but then it moved on. I don't think today it would be even allowed. I think we just, this is it, and we'll move it on. So. Okay, so compromise with evolution. There are some compromises out there. Macroevolution is accepted as fact, even if it's all called a theory. They still call it a theory, but it's accepted as fact. In scientific circles, it is accepted as a fact, okay? Even though it's still technically a theory, all right? It is taught in schools from elementary through high school and college. It's just pervasive. And that's in conservative Texas, Charlotte. Think about what it's going to be like in other parts of the country that are far less conservative. It's going to be even more so. Newspapers, magazines, books, even Hollywood are big progenitors of evolution. It's just accepted across the board. And I know Bob needs to go, so if y'all need to go, that's perfectly fine. And you'd like to work your way down the hall. The result of that is that many believers have sought a way to reconcile their faith in God or the Bible with evolution. And so, with no further ado, I will tell you that those compromises are in the following charts in your papers. Read those and study those. You can also look at the second set of papers that has scientific difficulties with evolution, and take a look at all of those things, and that's going to finish our class.